Hello everyone, I am Rohit Reddy. This is my presentation book. I am going to present the system implementation and methodologies in mini project flight fare prediction web application deployment. The domain is machine learning. System implementation. I implemented a machine learning lifecycle of this project to create a basic web application that will predict flight prices using a machine learning algorithm with historical flight data using Python libraries such as Pandas, NumPy, Matplotlib, Seaborn, sklearn, Pickle, and Flask. This is the life cycle of the project. First one, we import the libraries. The next is we can import the datasets. The next step is data preprocessing. We can club the training data and testing data. The next is the data analysis. We can finding out value counts and different relations. The next step is future extraction for doing various operations on data. The next one is future selection, which we can find the relations and we can visualize the heat map. The next step is model building, which we can use ML algorithms to create a model. The next one is Python Pickle model, data stored in binary mode in .pkl file. The next step is web application model, creating with the help of Flask tools and features. And lastly, we can deploy the model and we can find the predicted price. The next, what are the methodologies can be used? First one is data extraction. It is a process of retrieving the data out of a source which is used for feature pre-processing methods for creating structured data. It has two datas. One is the training data and is the testing data which can be downloaded from Kaggle. Totally, it consists of various factors which affects the price of a flight ticket, including the price of a particular flight. It contains 10,683 rows of data. The features present in the dataset are airlines, date of journey, source, destination, route, arrival time, duration, total stops, additional information, and price. And next is data preprocessing. Data preprocessing is a required important task for cleaning the dataset to produce understandable data. Next is the future engineering. First in future engineering, first one I want to tell is the future extraction. I noticed that string formats used to store the majority of the data, that every future data is retrieved such as date of journey column is string format which needs to be converted to integer data type. By changing the data type of date of journey, splitted the columns into date, month and year and added to the dataset, and data type changed from the object to int64. Even same as the arrival hour, arrival minute and departure hour also. Next is the future selection. To enhance the model performance, a future extraction approach is used to investigate the level of influence of each information on the prediction outcome. Next is the data visualization. A heat map is a graphical representation of data where values are depicted as colors on a two-dimensional grid. It is commonly used for visualizing the density or intensity of data across different categories or geographical areas. This is the correlation between all features of the heat map in the image. Next is the machine learning model. When deploying the ML model, I understand the random forest for prediction as this model demonstrates the best performance on data compared to other algorithm techniques. First one is label encoding. Label encoding is a technique that used to convert categorical columns into numerical ones so that they can be fitted by machine learning models which only takes numerical data. In ML algorithm, it has a different libraries. First one is lasso. In statistical and machine learning, lasso is a regression analysis method that performs both variable selection and regularization in order to enhance the prediction accuracy and interpretability of the resulting statistical model. Next one is extra-tree regressor. Extra-tree regressor is a machine learning algorithm used for regression tasks. It belongs to the family of decision tree algorithms and is an extension of the extremely randomized trees algorithm. Next one is random forest. Random forest is an ensemble learning technique where training model uses multiple learning algorithms that combines individual results to urge a predicted result. A random forest regressor is a meta-estimator that fits a number of classifying decision trees on various subsamples of the dataset and used averaging to improve the predictive accuracy and control overfitting. Next is the randomized search CV. The main advantage of using randomized search CV is that it can help you narrow down the range of hyperparameters that yield the best performance of your model, without the computational cost of exhaustively searching through all possible combinations. It is particularly useful when you have limited computational resource or when the hyperparameter space is large. Checking the errors values by using matrices. Evaluating the model accuracy is an essential part of the process of creating machine learning models to describe how well the model is performing in its predictions. It has three types of matrices. First is the mean absolute error, second one is mean squared error, and third one is root mean squared error. First one is mean absolute error is basically the sum of averaging of the absolute differences between the expected and actual value. Next one is mean squared error. Squares the difference of actual and predicted output values before summing all rather than using absolute value. Next one is root mean squared error. Root mean squared error is measured by taking the square root of the average of the square difference between the prediction and also the actual value. The next one is importing pickle library. The file extension.pkl is used for storing serialized objects in Python. The WB mode is used to write binary data to the file, and the RB mode is used to read the file in binary format from the file. The data fpp.pkl file is a serialized object file that contains a trained machine learning model for predicted flight prices. Next one is web application model deployment. Model deployment is the last stage of flight fare prediction machine learning project by using Flash to make an HTML file for flight fare prediction. This will take the input value for each feature and calculate a price of flight as shown in the image below. This is the web app deployment page where the price of the flight can be predicted by inputting the data. Date of departure can be selected from drop-down calendar. Date of arrival can be selected from drop-down calendar. Traveling from source can be selected from drop-down menu. Traveling to destination can be selected from drop-down menu. Number of stops can be selected from drop-down menu, and the preferred airline can also be selected from drop-down menu. And lastly, we click the predicted price and then it shows the predicted price value. So thanks for watching.